Graphing straight lines. We've already had some experience with the graphing mode of the calculator toward the end of Chapter 1. We do a lot more graphing here in Chapter 2, and I just want to make sure that we've covered everything we need to for straight lines. So I've got 4 examples here. We're going to start with example 1, where we're asked to graph the line y is equal to 2x minus 1 in the standard window. Now notice in all of these examples that the equations are all given to you in the form y equal to some function in terms of x. Now in your textbook you don't always get the lines in this form, so if you don't, you'll need to solve them for y before you can put them into the calculator. And the fact that we work off of that y equals menu is a good memory tool that we need to put things into that form. And when we do that, we're actually putting things into slope-intercept form at the same time. So to graph the line y equals 2x minus 1 in the standard window, we need to start by going to the y equals screen in the calculator. We need to type in this case, y1 is going to be equal to 2x minus 1. We'll press enter. And then to graph that in the standard window, we'll press zoom and 6 for zoom standard. And here's what we get. We get a line with slope of 2. That is, for every 1 unit to the right we move in the x direction, we'll go up 2 in the y direction. And we have a y-intercept of 0 and -1. We can see that here on the graph as we look at it. If we want to check out specific values, we can press the trace key. And again, if we use the trace key and move left and right, we get kind of weird values. But if we want to check out anything specific, like let's say x equal to 3, we can just simply type in 3. Press enter, and there we go. So when x is 3, y is 5, and we can go through and kind of evaluate that function for different values of x. If you're given the value of y and you need to figure out what x is, there's a little bit more work involved there. And we've actually already talked about some ways that you might be able to go about solving that. In example 2, we're asked to graph the line y is equal to -1/2 x plus 8 in the window x, -5 to 20, and then the subscript of 1 means tick marks of 1, and y -5 to 10 with a subscript of 1. So what these boxes tell us, and I may use these from time to time in the course, is that you're going to set x min to -5, x max to 20, and x scale to 1. And you're also going to set y min to -5, y max to 10, and y scale to 1. This is a nice shorthand notation for giving you all 6 of those values for the window. So let's put in the function first. So let's go to the y equals menu. Let's clear out the last equation that we had. And now let's let y1 be equal to negative. And then just to make sure everything works out right, I'm going to put the fraction 1/2 in parentheses. You don't have to do this way, but it's a good habit to get into, and it does help enforce the order of operations. So that gives me -1/2 times x, and then we want plus 8. All right, and then we are given very specific window values, so we're going to go into the window screen. We're going to set x min to -5 and press enter. We're going to set x max to 20 and press enter. The x scale of 1 is fine. We're going to set y min to -5 and press enter. And we're going to set y max to +10. That's what it already is. Y scale should be 1, and it already is. So once we have all those window values set, we can press graph and see what we get. So here's what our axes look like under that window. Our x goes from -5 out to +20. Each tick mark has a different distance of 1 between it. On the y-axis, we go from -5 to +10. And this window is chosen. We can see the y-intercept very well and the x-intercept very well. And those are two important features of the graph. So that's why this particular window was chosen. Depending on what you need to do with the function, another window may have been more appropriate. There are lots of different windows you can obviously choose for different equations. Had we not chosen this specific window and used, for example, just a standard window, we still would have been able to see the y-intercept, but we wouldn't have seen the x-intercept. X negative 10 cuts off about midway between the y-axis and the right-hand side of the screen. So this window is changed a little bit for viewing. And you have the ability to make that window whatever you want. So you can view things as best you can and to view features as appropriately as you can. In example 3, we're given the line y is equal to 50x plus 300, and we're just simply told to graph it in an appropriate window. All right, so let's start by going to the y equals menu. Let's clear out our last equation and put in this new one. So we're going to have 50x plus 300, and we'll press enter. And we need to come up with an appropriate window. Well, if we look at this, these are pretty large numbers. As a matter of fact, when x is 0, y is 300. When x is 1, y is 350. So we're going to need to have a fairly big y max to see very much in this. So noting a little bit of that, let's just kind of guess at a window. And let's say that we start with x min maybe being 0 and x max being 10. Get that entered in correctly here. 0 and 10 for x min and x max, and the x scale of 1 will work just fine. And let's let y min be 0. But we can actually do fairly quickly the math. If we take 50 times 10, that's our x max, we're going to get 500 plus 300, that's 800. So let's go a little bit above that. Let's say maybe go to 1,000. Now we don't want 1,000 tick marks on our screen, so let's maybe put our tick marks every 50. All right, and let's see what happens with this. So let's press graph. We're graphing in just the first quadrant here. And we see that we start with the y-intercept of 300, 0 and 300. And we work all the way up to our largest value here. Now again, depending on what it is that we mean to do and what it is we need to discover, this may be a perfect window. We may need to do something else. But this does a nice job of showing us what's happening from x of 0 all the way out to 10 with this function. We see it going from a value of 300 up to 800, and we can see all that very clearly. We can see both the axes very clearly, so we can see the relationship vertically to 0, and we can also see the left axis, so we can see that we're starting with x equal to 0. Again, this is an appropriate window. There are others, and if we had more context, if this was, for example, a story problem, we may need to do different things, and that would have caused us to adjust the window as needed. Our last example here, example 4, asks us to graph the lines y equal 5 and x equal negative 2 in the standard window. So let's go back to the y equals screen. Let's clear off our last function. And let's start with the first of these two functions. Y is equal to 5. So we'll let y1 be equal to 5. No problem there. The second equation we have here, though, is rather interesting. It says x is equal to negative 2, and there's no y anywhere. Since there's no y, I can't write it in the form y equal to something, so I can't enter it on this screen. As a matter of fact, this is going to turn out to be a vertical line that passes through negative 2 on the x-axis. So let's graph the first half, just y equal to 5 in the standard window. So I'm going to press zoom and 6 for standard. And there we get the horizontal line at a height of 5 all the time. The y coordinate of any point on that line is always 5. We're always 5 units above the x-axis. To get a vertical line on here, we need to go to the draw menu. So we're going to press second and draw. And we're going to say that we want a vertical line. And we have the ability to move around here. So let's go to negative 2 using the left cursor key. But there's a problem. I can't get to exactly negative 2. I can get to negative 1.9. I can get to negative 2.1, but not to negative 2. So let's see what happens if we type in -2. Oh, that didn't work. It took us off to the calculate screen. All right. As I pointed out in the plotting points, you have to be very careful with the draw menu as to whether you're on the graph screen or not. And this is a case where it's useful to not be on the graph screen. So let's clear this. Let's press second and draw again. Let's choose vertical line. And now let's just type in -2 after that vertical and press enter. And there we get the vertical line at -2. Now, if we'd been able to get to exactly -2 with a cursor key, we could have pressed the enter button on the calculator and it would have given us the vertical line exactly at the x value we were at when we pressed enter. But we couldn't get to exactly -2 using the trace mode, and that's what forced us off to the calculate screen. So we could type in exactly -2. Now, there's not a lot you can do here. We've drawn this vertical line, and we've plotted, if you will, the horizontal line. So we can't use like intersection functions and things like that. Although the intersection here hopefully is rather obviously -2,5 with these two types of lines. So you do lose some ability to do certain math things with the vertical lines, but you can still put them up here through the draw menu. That's a pretty quick overview of straight lines. As with most things on the calculator, sure, there are more you can do, but that should get you up and running for the beginnings of Chapter 2.